Hi everyone, I'm Nemanja from Ethernal. We are the company that deals with protocol level development and the bridges. Today my plan is to explain how the bridges who deals with multi-chains actually work. So to build one bridge, which can handle more than 2 chains. I will give some rough overview of architecture, and later on I will introduce some real-world projects that are built on top of that architecture. So let's get started. First of all, we need to know why we actually want to build this. The most common thing is that we want to exchange messages between the bridges. We need to send we need to send assets, and so on and so on. What we want to do is not to create a bridge between each 2 chains, but we want to have like a single bridge and then just plug in chains into that bridge, define some routes for communication between those bridges, between those chains, sorry, and everything should work. The bridge will send a message where they should be sent. Again, there should be like a simple way to introduce new blockchains into this system. We will explain how, maybe implementing 1 or 2 additional components which are added to this system. And at the end, something that is also important, we expect that end users of our bridges will get some additional funds. Will be rewarded for that. We'll see how that will happen. So this is the goal. We have a bridge in the middle, and all the other chains are there connected to the bridge, and they communicate to each other. And this is like a message passing mediator, a router who knows which message should go where. How is that implemented? Let's have like a high-level overview. First of all, we do not want to have like a single entity to operate that bridge, to govern that bridge. Instead of that, we want to have like multiple parties who need to cooperate together and control each other. And in that way, during their operation, they need to decide about bridging requests and messages which should be transferred from one chain to another. What is else important? Since we have like more than one entity and they're controlling each other, they need to achieve some kind of consensus to pass the messages from a chain to any other chain. The thing is that we already have a technology for that, and that is a blockchain. Blockchain is actually something that already has a built-in consensus, and that consensus can be used to decide how the bridge is going to operate. So the main thing is that we are going to use an additional blockchain in some components which will be added to the nodes of that blockchain to build our bridge. And for those purposes, there is a blockchain named Blade. I talked about this blockchain last year on this conference and how it can be integrated into enterprise environment. Meanwhile, this Blade blockchain got additional models, and now it's tailored to build bridges on top of it. We'll see how that will happen. So, as I said, we are building something like this. We have a chain in the middle, and this chain behaves as a bridge. So let's call it like a bridge blockchain here. All the other chains need to communicate to each other, and the messages from any chain to any other chain just pass through these validators to this blockchain here, through the bridge blockchain. They need to validate if the request, the bridging request that occurred on this chain is good enough to be forwarded to the destination. For example, this chain here. To simplify this picture a little bit more, let's assume that we have only like 2 chains. And how is that done? Every of the validators of our bridge blockchain need to monitor, observe this chain here. They need to figure out if anyone has sent a bridging request, like some tokens or some kind of general message, to be transferred to the destination. They need to detect that bridging request. All of them need to verify that the bridging request is correct. And afterwards, they have to reach a consensus that everything is okay. The majority of them has to agree that everything was done correctly on this side of the chain. From that point on, they need to build a transaction that is going to invoke a destination chain and transfer, for example, tokens which were locked on this chain here, like on the source chain. How is that done? Obviously, validators are built only to create blocks. And we need to introduce some additional components, let's call them like trusted components of these validators which are going to deal with reading these chains here. And it looks like this. So, again, every validator in our bridge blockchain gets an additional component. We named it Oracle in our study. And that Oracle, the responsibility of that Oracle is to observe chains in this system. So Oracle, for example, Oracle 1 has indexer that reads this chain and that reads this chain as well. Again, validator 2 has the same Oracle, and so on and so on. So when Oracle detects that some bridging request has occurred here on chain 1, it somehow has to reach the consensus within this blockchain that the bridging request is valid, that is correct, and afterwards it should be forwarded to the destination chain. There are like 2 approaches how the oracles can reach a consensus that a submitted bridging request here on chain 1 is valid, is correct. The first one would be that oracles communicate to each other. So there is like a dedicated communication line between the oracles where they can exchange messages, exchange votes about bridging requests. Let's take an example. I think it will be easier for me to explain with a simple example. The bridging request arrives on chain 1. Oracle 1 detects that bridging request, and Oracle 1 has some kind of storage here. Oracle is going to write that bridging request into that storage. Then the Oracle 1 is going to create a vote. It's going to sign some kind of message that represents that bridging request, for example, hash of that bridging request, and send it to Oracle 2, and Oracle 3, and Oracle 4. All of other oracles are going to receive that message, that vote. So now, Oracle 2 has a vote from Oracle 1 in its storage. In the meanwhile, Oracle 2 can also read the same bridging request. And then Oracle 2 sends its vote to the other oracles. The same applies for Oracle 3 and Oracle 4. So there is like a storage for each oracle where they like sum up all the votes regarding the bridge request that occurred on this chain here. Now we need to see what is the purpose of blockchain in this situation. These validators are going to create blocks. And let's assume that validator 1 is a proposer of a block. So the proposer reads transaction pool, includes all the possible transactions in the block, and then at the end of the block, it pings its own oracle and says, okay, do you have any kind of bridging request here that has collected enough votes from all the other oracles, which means that like majority of the chain of this system has agreed that that bridging request is valid and that it has occurred on this chain. If there is such a bridging request here in Oracle, Oracle is going to return it with all the votes that has in its internal storage. The validator, the proposer, is going to introduce another transaction into the block, and that transaction is going to hold the bridge request plus all the votes from the other oracles. When that block is created, the proposer sends it to all the other validators. And then, for example, validator 2 verifies the block. At a certain point, it will read the transaction that holds the bridging request. And validator 2 then asks its own oracle, okay, does this bridging request has enough votes? Oracle 2, because it has collected enough votes for that bridge request, is going to return yes. So validator 2 will confirm the block. The same will happen with other validators. So at the end, we are going to have a block which is included into our blockchain system. And there will be a transaction within that block with all the votes from the other validators that confirm that everything was correct on chain 1. Now the only thing that is left that somebody pick up that transaction, extract bridging request, and send this to the destination. In our case, this is chain 2. That is one of the approaches. The second approach looks like this. So instead of oracles communicating to each other directly, we deploy something that we call bridge smart contracts. And bridge smart contracts are actually there to count the votes of all the oracles in the system. So this oracle here reads a bridging request from the chain 1. The oracle creates a transaction and sends it to this validator. The transaction, of course, aims to update this smart contract. The same thing happens with Oracle 2. It sends a transaction and sends it to this validator. Again, the same thing with the remaining 2 oracles. Now, in the transaction pool of these validators, there are transactions which should update these smart contracts with votes from each oracle. And validators use their internal consensus, for example, IBFT or whatever, to include those transactions into the block. When they include those transactions into the block, this bridge will get updated because the transaction included deals with this bridge. They're applied on smart contract. And now this smart contract here has enough votes to prove that all the oracles have read a bridging request from the source chain and that bridging request is correct, that it is valid. The only thing remained to do so now is that someone reads from time to time this bridge smart contract, ping it from time to time, and sends the bridging request to its destination. So we need at least one trusted relayer who is going to read this and submit it to the destination blockchain. So this is really like a high-level overview how this bridge works. This is how it actually works. I'm not going to dive deep into this picture, but as you can see, there is like a user, there is a source chain, a user submits a bridging request, Oracle detects bridging request, then there is like consensus way for everyone to agree that everything is okay. If everything is okay, Relay is going to pick up that bridging request and submit it to the destination chain. If anyone is interested, we can discuss this after the presentation. So now I want to move on to some, as I said, real-world implementations of such architecture. The first one is Reactor, this bridge here. At the moment, there is a new ecosystem emerging. As we speak, it emerges. So the name of that ecosystem is Apex Fusion. And the purpose of that ecosystem is to connect UTXO world with EVM world. So in that ecosystem, there is like a chain named Prime that is Cardano-like chain. So it is a UTXO chain, as we all know that Cardano uses UTXO. There is Vector, again Cardano-like chain with UTXOs, and we have Nexus, which is EVM chain. They all need to communicate, of course, for this ecosystem to work properly. The bridge that does that communication allow exchange messages, exchange tokens between these chains is named Reactor. A little bit more about the architecture of Reactor. So, as I said, we have Prime on our left, we have Vector on our right. Both of them are Cardano-like chains, and we have Nexus, which is EVM chain. What is like a really, really nice thing about Cardano, what I really like, is that out of the box for Cardano chains, you can create multi-signature addresses. So addresses which are controlled by multiple users. The other really nice thing about Cardano is if you send a transaction to the Cardano chain, there is a field name metadata, and you can write whatever you want, sorry guys, whatever you want into that field. And we intend to use that. We tend to use that method. Okay, something is wrong with laser. Something is wrong here. We tend to use that. I'm not pushing anything, so. Okay, we tend to use that multi-signature address and metadata. I'm not doing anything, something is switching by itself. Let's try it now. So we intend to use multi-signature addresses for Cardano and those metadata in these bridging purposes. This multi-signature address on Prime is going to be controlled by the validators of the bridge. The same multi-signature address exists on Vector. And since there are no multi-signature addresses on EVM chains, we need to create a smart contract. And as you all know, smart contract can be, again, controlled by multiple users, as those users are going to be these validators. So when someone wants to send tokens, for example, from Prime to Vector or Nexus, or even both chains at the same time, it just creates a transaction. In the metadata of that transaction, writes what is the destination of those tokens. And the transactions is intended to update this address here. Validators are going to read what is happening on this address. And when majority of validators read that something has happened, that a bridging request has arrived, they need to verify that bridging request, and if everything is correct, they need to create a transaction which will be submitted to Vector to unlock tokens from this address to the user, or the transaction that will be submitted to Nexus, which will ping the smart contract and unlock tokens from smart contract to the user here. In some cases, if a user wants to transfer tokens to both Vector and Nexus at the same time, validators need to create two transactions, actually, one for Vector and one for Nexus. So that's it regarding the reactor. The other bridge I wanted to talk about is named Skyline. The purpose of Skyline is to connect Cardano world with Apex world. This solution will be live in the following few weeks. So we expect the mainnet quite soon. So now how this thing operates. At this moment, right now, we can say that Skyline is a subset of feature for Reactor. But later on, I will explain some additional enhancement. So we have Cardano chain, multi-signature address here. We have Apex side. The representation of Apex side is a prime chain, and again, there is a multi-signature address here. Both of these multi-signature addresses are controlled by the bridge validators. To repeat myself, if you want to send something from Cardano, you said like a bridging request that locks token on this address. Validators are going to verify it and confirm it, and then send a transaction to unlock tokens from this address to the user itself on Prime. So that is how the Skyline looks at the moment. But it is planned to be really, really enriched in the future. What is going on? We want to have like a feature that if you use Skyline, you are going to get some additional rewards. So we are not going to take any money. We are going to give you some tokens for it. And we intend to use staking for these purposes. I will explain how that will happen. Again, that process of staking shouldn't be controlled by a single entity. Again, we want to create a distributed staking. So more than one entity should be responsible that a user who actually utilizes Skyline gets their rewards. And hopefully, not hopefully, it will be completed until the end of this year, probably even sooner. So how that works? Let's get back to our original picture. I'm a user. I want to set some tokens from Cardano to Prime. I will create a transaction that holds some metadata, and that transaction is going to set tokens here on this multi-signature address. Validators are going to read that bridging request, as I said, verify, get a consensus, everything, and they're going to ping this multi-signature address here, and I'll unlock tokens for me on Prime side. And now I can do whatever I want with my tokens on Prime side. But what's the thing? The thing is that these tokens here on Cardano side, they're just locked, sitting there, unused. So maybe we can use something with them. As I send metadata for my transaction here to lock the tokens, I can outline one field which says, okay, I want my tokens, which will be locked here, to be used to earn some additional rewards. And then, for those purposes, of course, we need to have some more code for this bridge blockchain, and we need to have additional components. We call that additional components stake managers. Stake managers are going to read this multi-signature address and check if there were a transaction in which metadata somebody outlined that wants to use tokens locked here for getting rewards. This stake managers read that kind of situation, and of course they need to agree that everything is correct. So we need to have a consensus between them as well. And when they reach that consensus, they all agree that the tokens from this address can be delegated to the stake pool of this chain. So the tokens actually, which are locked by the bridge, can be delegated to stake pool to earn some rewards from those tokens. Now, let's get back like a step back. I'm a user who spends or uses, employs their tokens here, my tokens here. If I want to return to original chain, then again, I can start a bridging request from this side to the Cardano side, and when everything is verified, I need to get my tokens which are on this multi-signature address, which were previously locked, which I have locked when started the first bridging request from Cardano to Prime. So I will then get tokens that I have initially locked, plus all the rewards from the stake pool that were created from those tokens that were locked here. So I get more when I return into this ecosystem than when I actually started moving tokens from one side to another. Of course, everything can be done on the Apex side as well. We can, if we move Apex tokens from Prime to Cardano, the same process occurs, and we can stake them here. So that's the story about the staking. We would really like for Skyline to end up looking something like this. So Skyline currently supports Cardano and Apex ecosystem, and in the future, hopefully, we will be connected to the many other chains like Ton, Solana, Polygon, and so on. That's it, guys. I'm ready for questions. Any questions? Any questions? Okay.
Thank you for the wonderful presentation. I have a question on what would be a theoretical limit to the number of different networks a bridge like this can operate and facilitate bridging for?
I'm not sure right now. Well, theoretical limit, like limitless. Hopefully we can add like a bunch of chains here. It depends how fast this blockchain is going to work. I think that like 10, 20 can be easily like introduced into this kind of system. Yeah. Anyone else? Okay, guys, then probably we should wrap it up and finish. Thank you, everyone.